This question says the curve has a stationary point when x equals 2. So the stationary point is when dy by dx equals 0. So the first thing to do is going to be find dy by dx. So if we differentiate x to the n, it's going to be nx to the n minus 1. If I've got constants in there, I just sort of carry them through. So dy by dx, and multiplied by the 3, I'm going to get 6x squared plus 6x minus k. And we're told, this is part A, we're told this equals 0 when x equals 2. Therefore, we can substitute in, we're going to get 24 plus 12 minus k equals 0. So k is going to equal 36. That seems quite a lot of marks just to do that, but I suppose we've had to differentiate, we've had to recognize that what stationary point means. We've substituted x equals 2 and we've rearranged and solved the equation. Okay, part B, determine whether the stationary point is a maximum or minimum point. Two ways to do this, but the first, like the good recommendation is always just to find the second derivative, just because it tends to be a bit quicker. Okay, so second derivative, we're going to take this thing here and differentiate it again. So we're going to get 12x plus 6. And then we're going to substitute in our stationary point when x equals 2, d2y by dx squared equals, this is going to be 24 plus 6, 30. This is greater than 0, so it's a minimum. Just quickly, I'm not going to go into detail on this, but why does it mean it's a minimum? Well, because the second derivative is positive, it means at the stationary point, or like around the stationary point, the gradient itself is increasing, which is what happens for a minimum, as opposed to a maximum, where the gradient itself is decreasing. That's why the second derivative would be less than 0 there. There are cases where you get the second derivative equal to 0 as well, and then you need to use another method. And that other method is to look at the gradient itself to the left and to the right of the stationary points. And if it's negative to the left and positive to the right, then you get a minimum. Whereas if the gradient is positive to the left and negative to the right, then you'll get a maximum. See, at the stationary point it's equal to 0. So I just wanted to talk about that quickly, but in this case, just find the second derivative and it works out really nicely.